Welcome. In this video, we'll be demonstrating how you can quickly build real-time analytical models on device data through Software AG's CUMULOCITY IoT platform. We'll also explain how CUMULOCITY's self-servicing analytics capabilities can quickly provide an entry model into monitoring the behavior of sensor data in real time. In particular, we'll be composing a common method utilizing statistics in the form of Bollinger Bands to gauge initial forms of anomalous behavior on the sensor data itself. For this exercise, we'll be employing our own sample temperature device and simulated data. If you would like to make use of prepared scripts to run sample devices and measurements, please refer to the links at the end of this video. First, let's start with a quick background summary of CUMULOCITY's analytical capabilities. As you may already know, CUMULOCITY is the leading IoT platform in the market, not only for device provisioning and management, but also for its leading-edge streaming and predictive analytics capabilities and features. Embedded within the platform, you'll find components to quickly construct analytical models on the consumed device data. This includes both streaming and predictive analytics that can be deployed on both edge, on-premise, or the traditional cloud infrastructure environment. This allows for great flexibility in defining where in the data integration chain to apply the data processing. For example, you may want to provide direct actionable insights on the edge for faster response times or scenarios with intermittent connection to central control. In other cases, we may want to have a centralized analytics process on the cloud to aggregate multiple device data sources simultaneously. For real-time analytics, we'll be employing the streaming analytics features of the platform. These analytics can be constructed and deployed in multiple ways as well. For example, we may want to make use of pre-built analytical models in the form of smart rules that you can just configure and enable. Or we can make use of CUMULOCITY's Analytics Builder to visually construct the data processing workflow with various types of inputs, outputs, such as alerts, notifications, events, and even new synthetic measurements which we can publish to our solution. And this, of course, is what we'll be doing today. Alternatively, you are also able to script together these analytics through our EPL apps module, through our event processing language, which provides a very rich syntax to build this out on. You are also free to deploy any form of analytics, such as our own APAMA streaming analytics solution that we have so far mentioned, into a custom microservice container as part of CUMULOCITY's orchestration mechanisms. Finally, you're also, of course, able to deploy completely independently any analytical solution outside of the platform with the ability to consume and publish data through the set of CUMULOCITY's API options. The Analytics Builder, as you'll see in our demo, aims to provide a visual no-code developer environment to compose the analytical workflow. It is comprised of a set of blocks that define your typical inputs, outputs, and most common types of processing modules in between. You're able to control the lifecycle of these workflows by activating or deactivating them at any point, as well as the ability of calling one workflow from another. We'll employ these blocks to put together a Bollinger Band computation for a temperature sensor. As the temperature readings flow through the platform, we'll be using the strategy to detect any time periods where the temperature readings drift too much from the baseline. In other words, we'll be looking at the mean of these measurements over a moving time window, construct upper and lower limits on the deviation from the mean, with some multiplier factor of course, so we can detect when the actual measurements breach either of these limits. These upper and lower bands is what defines the Bollinger Bands, with a very straightforward but common approach for detecting these types of patterns. So let's move on to building our Bollinger Bands. So let's navigate first to the device management window in CUMULOCITY. You can see I already have one device here deployed, a temperature sensor with some simulated data behind it. Let's just look at what it holds at the moment. We'll look at the measurements that are already been produced. And as you can see, we have a good sample of different temperature measurements already in the history of the device. So let's proceed now to our analytics builder and build some of our Bollinger Band analytics around these then. Let's select from our menu the APAMA Analytics Builder. In our Analytics Builder, Let's create a new model. Let's call this model Bollinger Bands. Select OK. Now we have a black canvas to work with. And you can see on the left-hand side, I have all the different inputs and outputs that I want to construct my analytics with. So we're going to build this out first by constructing the mean. But first, we, of course, need to select which sensor measurements we want as an initial input into our workflow. So we'll go into our input and look for our temperature sensor. It'll be the first one in our list here. And we'll drag that temperature sensor onto the canvas. Now this is a measurement input, of course. We select which device we want. It's already pre-selected for you. And we select now the fragment and series that we're interested in measuring. In this case, it's only one fragment and a series of T. That is our temperature in Fahrenheit. We'll select that, and we're done there with this particular block. So now we have our input. Now, next, what we want to do is build our average or mean over a moving time window. That's going to be our kind of a baseline to go from and build our upper and lower bands from. So we'll do an aggregate calculation. We'll select the average, place it on the canvas. We'll move the value from this point to the value input of the average block. Okay. We click inside of the block, and we can input now the duration of that moving time window to calculate the average against. That is, all the data points inside of moving time windows will be part of the average calculation. So let's select just for arbitrary number of 60 seconds for now. We'll select that, and now we have our average configured. Next, we'll compute our standard deviation from the mean. So in the same way, in our aggregate function here, we'll select it and move it over to the canvas. We'll get the value of the measurement into the value of the standard deviation block. Following that, what we want to do is create this upper and lower Bollinger Bands, which are defined as a standard deviation times a factor away from the mean. So let's put that together. Now we want to put a arbitrary formula here to create that value of the upper and lower bands. So let's select a calculation as an arbitrary expression. Now in my expression here, I have an option to include any of the input parameters in my free-form expression. In this case, I want to say that if I'm going to be putting the mean into the first one, this is, by the way, constructing the upper band, into the first one, I refer to the value of the first input times a factor, unless for just pick a factor against the mean. So it's 4 times, and let's assume that in input 2, we'll have the standard deviation. Okay. So now all that's left is connect this together. So now we put the average into the first input and standard deviation into the second input. Now we have the calculation of the upper band. Same thing we can do for the lower band. The only thing we need to do here is duplicate this, as we're only going to change the sign here in the expression. Duplicate it. Let's move it a little bit down. Let's place the average in the first input and the standard deviation in the lower input. Okay. Click inside, and let's just change the sign in the expression. So now that gives us the standard deviation with a factor away from the mean. Now we have the results here where we're not doing anything with them at the moment. So what we want to do is, first and foremost, let's just send those measurements as synthetic measurements back into the platform so we can visualize them and render them in one of our widgets. Let's do that right now. Let's select an output. Let's select the same device again, because we're going to be issuing the measurements to the same device back. Let's look for it. Temperature sensor 1. Place it in the canvas here. And we want to have a new fragment type because it's going to be a new synthetic measurement for us. Let's call this CUMULOCITY 8 metrics. Let's call the series name upper band. We set the input to the value and we're done. In the same way, let's create now our lower band. Same way, the easiest we can do is just duplicate this very same thing because we're going to create a new measurement. Let's connect the value to the value. And let's pick a different series name for it. Let's call it the lower band. Now the units should be the same thing as the temperature, but let's correct this one and let's correct the upper one as well. Fahrenheit reading. Very well. So now we're done. For completion, let's also add the mean results to the measurements. So we'll just copy this and let's just also publish the mean results. Let's call this the mean. So now what we want to do is save it and close this. And now by default, you have different modes in which this particular module is configured for. So you have a draft, we have production, simulation, and for testing. But let's say that we're feeling confident today, and let's just put it right straight into production. Okay, so that's a production, and we activate it. Now we navigate back to our device management console and into our temperature sensor device. We look at the measurements, now the ones that we had before. You can see we had a few other measurements here on the temperature side being published. And as you can see, if we let it run for a while, and this of course is after a few minutes after the fact, for the sake of the video, you will see now your Bollinger Bands being published with the mean in the middle, hopefully within the middle of the bands as well. So any breach in those Bollinger Bands might suggest some sort of anomalous behavior in the sensor reading and the sensor device itself, of course. This concludes our demo. You can find various examples, including scripts for creating devices and generating simulated measurements in the following link. And you can also find the latest documentation on Cumulocity and its real-time analytics capabilities in this following link as well. Thank you.